Okay guys, we're going to go over the independent practice, which I gave you, which was on page 63. I asked you to do 1 through 9 odd, and then number 10. Now, the simple answers are, if you can see, number 1 is no, number 3 is yes, number 5 is no, number 7 is no, number 9, you have to watch the video, because there's a little explanation I have to give, and same thing for number 10. Now, obviously on the quiz, you're going to have to write a bigger sentence than just no and yes, but for now, you have the idea. So if your answers are great, you got them all perfect, move on. You don't have to watch the video. If you got some wrong, fast forward. If you got them all wrong because you didn't try or I don't know what happened, I mean, who am I to say, right? Just watch on, all right? All right, so let's get started. Number 1. I may not be as... my explanations may not be as detailed this time around because by now you should have an idea of what to do. And be aware there is more than one way to do these problems. So as I've been reading your discussions, what you do may be different than what I do, which is totally fine. Okay? If you get the answer and it makes sense to you, go with it. And if you want to share with me tomorrow in class, by all means, please do. All right. Determine if each pair of ratios or rates is equivalent. Explain your reasoning. All right. We have $3 for 6 bagels, $9 for 24 bagels. All right. I know for some of you, you're having an issue finding the ratio as far as what is it that we're comparing. And I know I said ignore the numbers. I'm going to backtrack and say go with the numbers. Okay, I see the word 3 for 6. So $3 for 6. Now what goes with each number? I noticed that 3, well, it's already dollars, that's already there. But for the 6, we have the word bagels. And then the other set of numbers, we have $9 for 24. Okay. Bagels. Might as well write the words too. So if on the quiz I ask you, what is the ratio? What are we comparing? You could write down dollars to bagels, because that's what it is. Or money to bagels, or something like that. Because I do want you to understand the problem itself. In a word problem, it'll be hidden. So you're gonna have to be able to pull out the story for the word problem. But this is pretty straightforward. Okay? Now, we have 2 ways of doing this. I'm looking at the problem. I have 3 to 9, 6 to 24. I notice I can scale up. So I'm going to go ahead and check out these 2 ratios, see them as fractions, and I'm going to see what happens with it if I can scale up. All right. I can definitely go from 3 to 9, scaling up. I can make 3 groups of 3 to get 9. To go from 6 to 24, I know I can scale up to go, I can do 4 groups of 6 to get 24. Now, if I'm looking at these as fractions, the factors that I scale up or scale down with have to be the same. Okay, you have to make the same amount of groups. So, 3 groups of 3, great. And then 4 groups of 6, well, that's not equal groups. It doesn't work like that. And I already explained in other answers, in other homeworks, so you know what I'm talking about. So, again, you're going to need 2 answers. Remember? 2 sentences. 2 answers. That just doesn't look right. That looks like an hamster or hamster even. I don't know what I just wrote. 2 answers. Okay. You need to give me the answer first, obviously. The answer is the rates are not equivalent. Okay. But now you have to give me the reason. The fractions are not equivalent. All right. So if you notice the pattern already, if you're going to say not equivalent, and just to make it easy for you, the answer or the reason also has to have that in there just to make it easy. Okay. Now, you might decide to make this into one sentence. The rates are not equivalent because the fractions are not equivalent. There you go. Or I noticed that the fractions are not the same. They're not equivalent. That tells me the rates are not equivalent. Like, however you want to write it. I'm just giving you something to work with. Okay. Now, how do we know that we're going to use fractions? Well, since I'm comparing fractions, that's my reason. Okay. Later on, if I do a unit rate situation or unit rate problem, you'll see why we'll use unit rate then, okay? You'll see why we do that. All right, so that's number 1. Number 3. Same thing. Are the rates equivalent? We have 3 hours work for $12, 9 hours work for $36. Okay, we have 9 and 12. No, excuse me. We have 3 and 12. They go together. $3 and $12. Now, what goes with the 3? Hours. I also noticed that I see, notice, see, kind of say the same thing. I have 9 hours. That just looks like a giant A, doesn't it? All right, let me move this up a little bit. $9 hours. And how much does this person make in 9 hours? $36. Okay, I could be tempted to turn this into a unit rate or unit price and all that, but I'm not going to. You know what? As always, look before you do anything else. What do I see? Just like any other problem, I can say I can scale up. If I can scale up, maybe I can cheat these as fractions and see what happens. But first I want to write the ratio. What am I comparing? I am comparing hours to money. And I'm going to use the dollar symbol because really that's what it is. All right, if I treat these as fractions, I have 3/12, 9/36. Okay? I'm scaling up. That means I'm going to have to multiply. I want more groups. Again, if you're scaling up, you want more groups of what's already there. So I want more groups of 3. I can get 3 groups of 3 to get me 9. And I can use, I can get 3 groups of 12 to get 36. Hey, look at that. The factor's the same. This is pretty straightforward. So the rates are equivalent. Why? Because the fractions are equivalent. So look, for the quiz, you're either going to say they are equivalent or are not equivalent. You know, maybe I should highlight that too. And I'm giving you a sentence to work with that should be easier to use. All right, so there's number 3. Let's carry on. By the way, if you saw that you wanted, if you decided that you want to change it into unit fraction or unit rate, unit fraction, what am I saying? If you want to change it to a unit rate, by all means you can. Like I said, you have the freedom here to do what you need to do to get this to work. All right. Number 5. It's a word problem. Jenny is comparing the cost of 2 packages of socks. Okay, we're talking about socks. One package has 8 pairs of socks for $12. Another package has 3 pairs of socks for $6. Are the rates equivalent? Explain your reasoning. Okay, I see 8 to 12. 8 to 12. And I also see 3 to 6. 3 to 6? 3 to 6. Okay. But what goes with the 3? Because the money part, it's obvious. Money goes with the 12. The dollar symbol. We're talking about money. Pairs of socks. I'll just put pairs. Pairs, 3 pairs of socks. And if I forget, I'll just put it here on the side. Socks. All right. Should I try using, you know what? Let's try this out. I could do the fraction deal. I can scale down. Let's try that. I know if I can divide 12 into 2 groups to get 6. Can I do that with 8? If I divide 8 into 2 groups, I'm going to get 4. Okay, that doesn't work. That does not work. Nope. It gives me 4. There's no match. So right away, I can tell they're not equivalent. But let's just say for sake of argument, I also see that 3/6, I recognize that as being a half. So I'm going to do a unit pair situation here. I'm going to do a unit rate situation. I'm going to check to see if the unit rates are the same. 3 to 6, 8 to 12. Treat them like fractions. But I'm going to find the unit rate of those fractions. All right. And actually, Maybe I don't want to do it, but let's try it anyways. I did say I was going to try it out. Right? Ugh. That would be 1/2 over 1. And I can already see where some of you are like, why is he doing that? Why couldn't he simplify that? We could, and I will. I'll do that as well. Let me just do this real fast. 8/12 over 1. If I simplify that, that gives me, right over here, 4/6. I should have divided by 4, but I wasn't thinking, and that's okay. I want to take my time and do this right. And that gives me, you're like, man, he's wasting a lot of paper. That's okay. You need to see this. Well, either way, it still worked out. I can still see the unit rate's not the same. Right? It's not. Okay? And if we did simplify it, like I wanted to say earlier, although really, how would you say that? Let's go with it. I already said it. Follow through, man. Follow through. 3/6. I'm going to treat it like fractions. 8/12. We already saw this simplifies to half, right? Divide by 3, divide by 3, divide by 4, divide by 4. We have 2/3. They're not equivalent fractions. These are not equivalent fractions. Okay, so you have a third option, I guess, when you write your answer. So you choose whatever works best for you. We saw that as fractions, they're not equivalent. We can't scale down. They don't have the same factor. It's just not going to work. Because this will be 8 divided by 2 point whatever. If I look at unit rates, I have 1/2 to 1, 2/3 to 1, not equivalent unit rates. If I simplify the fractions, 3/6, 8/12, I get two different fractions that aren't the same at all. So the first answer stays the same. The rates are not equivalent. Okay. Now for the answer, I will say, I'm going to say the unit rates are not the same. Okay. And that's 3. Okay, I know I finished this problem. I do want to go back and mention something. Part of the problem with being a teacher is I have to see as many possibilities as possible because all of you are different, and I try to see things as many ways as you might possibly see it. I can't do it, but all I can do really is see it my way and try and do best to show you many more ways of possibilities, right? Many possibilities. But in the end, find what works best for you. The idea for this lesson is to see if these rates, whatever you have in front of you, are the same. You can scale down, you can scale up, treat them as fractions, see if that works. You can find unit rates, see if that works. Or just, you want to just simplify right away and compare the fractions, which would be another way. I know the book doesn't say it, but some of you might have done that without me telling you, because really you're thinking ahead, and that's great. So if you just went ahead and did this and said, hey, the unit rate, the fractions are not the same. The rates are not equivalent because the fractions are not the same. You can say that too. And they're not. They're not equivalent in any way. Right? 1/2 is not equivalent to 2/3. 1 times 2 gives you 2, but 2 times 2 does not give you 4. Or sorry, 2 times 2 does not give you 3. And it should be 4 to make it work. Right? Okay. Let's keep going then. That was number 5. I know I said 3 earlier. I don't know why I said that. But let's keep going with it. Almost tore through the paper there. All right, number 7. On a math test, it took Kiera 30 minutes to do 6 problems. Heath finished 18 problems in 40 minutes. Did the students work at the same rate? Explain your reasoning. All right, again, it's one of those situations where you have many choices. But let's write the numbers. We have 30, and it goes with 6. And we've noticed that with 30, it's minutes. 6 problems. All right. And then we also notice we have 18 problems. Hold on. 18 problems. So if it's problems, it's going to go here at the bottom. And 40 minutes. Okay. Part of the problem was that the word problem itself, it said 30 to 6, right? 30 minutes to 6 problems. But then for the other one, it said 18 problems to 40 minutes. What you might have done was, if you weren't careful and I caught it, you might have put the 18 as the numerator, and you might have said, well, that's 18 minutes and that's 40 problems. So you got to be careful, okay? So here we go. Since we're trying to figure out how many problems they can do a minute, right? This is a per minute situation. I might want to change these into unit rate situations where I put the minutes at the bottom. Minutes at the bottom. Okay? But that's not the only way to do this. Again, the goal here, honestly, is just to see if these rates are the same. Okay? Now, nope, I don't see an easy way to scale up. However, well, this one I can multiply by 3, but there's no way 30 times 3 is going to give me 40. Okay? So what I'm going to do, just like with the other problem, I'm going to simplify them and see what happens. Okay, 30 and 6, I know I can divide by 6. That gives me 5 to 1. 40 to 18. They're both even numbers. I'm going to try 2. I have 20 and then 9. Okay? I can't simplify this any further. All right. So, as simplified fractions, let's see if I can scale up. I can go from 5 to 20 if I multiply by 4. I can go from 1 to 9 if I multiply by 9. I guess what I'm trying to say is, earlier I said you can do a unit rate problem. You can change it to something, how many problems per minute, But that's not what the question's asking. It's not asking you to figure that out. So basically you're going to be doing more work than you have to. I mean, seriously, I could have done 6 problems, 30 minutes. Okay, I'm just showing you another possibility. And if you did this, bravo. It's a lot of work. Well, not necessarily, but here, let's just go with it. How many problems per minute, right? So, 6 to 30, divide by 30, right? I don't even like where this is going. You can do 1 and then 1/5 of a problem per minute. Right? And there's another way you can look at this too. There's so many ways to do this. Ish. Oh my goodness. Oh my goodness. 9/20 of a problem per minute. How do I know that? Because I already did it over here. Right? 18 over 40 simplifies to this. But you know what? Let me show the work just so you can see what's going on. Let's see, 18 to 40, 18/40. It could be 9/20. That's just gross. I don't even like this. Now, of course, another way, if you'd left it the way it was, look at this. One problem every 5 minutes. One problem every 5 minutes. And this would be 9 problems every 20 minutes, right? So, either way, the point is, it's not the same. So, the rates If this part confused you, don't worry about it. If you understood it, great. This should have made so much more sense. Just keep it simple, okay? I always tell you guys that. Keep it simple. The rates are not the same. Why? Because the fractions are not the same. And you know what? I shouldn't say same. I should say they're not equivalent. But just for now, I'm going to let it slip just because it's too much to erase, and I think you guys understand what I'm saying. But on the quiz, be precise. The fractions are not the same. And by same, I mean equivalent. I'll put this on the side. Same meaning equivalent. Okay. But it's precise. It's more precise to say the rates are not equivalent because the fractions are not equivalent. Okay? Just had to make that clear. All right. Number 9. Sorry. All right, number 9. Let me draw the line down the line. Okay. This is one of those problems where it's not about the numbers. Okay? Identify the rate that does not belong with the other three. Justify your response. So in other words, it's saying, and I know the answer is there, but that's not the point. 3 of these belong with each other. All right? So what is it about those ratios? What makes a rate connect with another rate? What makes a ratio connect with another ratio? What makes a fraction connect with another fraction? All right? We have here, I'll just write it down. 4.5 feet per second. So per second for every 1 second. And then we have 112 feet, 25 seconds. And we have 86.4 feet, 18 seconds. $54 feet in 12 seconds. Okay, let me ask you the questions I just asked. What connects a rate with another rate? It's really what it's asking. What connects a rate with another rate? Remember, rates that are connected probably end up showing the same relationship, right? And if they're showing the same relationship, that means they are equivalent. So the goal here is to show which of these fractions are equivalent to each other. The one that doesn't fit is the one that's not equivalent. Now, I could do the math, but this is one of those things I think I need you to do it instead. All right? So what I will do is I'll give you an example that hopefully might make more sense to you. All right? And let me write the answer here already since I kind of already said it. What connects a rate with another rate? If they are equivalent, they are the same. Exclamation point. That's how important it is. Okay. The example I want to give you: 1/2, 3/4, 3/6, 4/8. I can ask you the same thing. I have 4 ratios, 4 rates, but I'm going to look at them as fractions. I want you to understand the idea. Which one of these fractions doesn't belong with the other one? Or other 3? Okay? Okay, I'm going to try to draw them as equally as possible. If you draw them, you'll see the answer right away. Half. Three-fourths. Three-sixths. Okay. Visually, I think you could see that this is the one that doesn't fit. This is the one that doesn't fit. Why? You have the smallest possible fraction here, half. The simplest form of the fraction, 1/2. This is the smallest it's going to get. You have the idea of 1/2. 3/6, even though the numbers are different, still shows the same value of half. 4/8 shows the concept of half. Shows the idea of half. The relationship. 1 for every 2. 1 out of 2. 1 out of 2. 1 out of 2, right? Okay, think of it as pizza. You have one big pizza. This is still half a pizza. This is half a pizza. This is half a pizza. This is not half a pizza. There's a connection. So, with this one, this is the simplest form. The trick here then is, and you can have to do this yourself, the trick then is to find out which of these two ratios connect, or, sorry, which of these, well yeah, which of these two connect, which of these two fractions are equivalent to this. So what I suggest you do, scale up to each one. Do 2 at a time. Right? And see if they're equivalent, if they scale up by the same thing. 1 times 25 gives me 25. Does 4.5 times 25 give you 112? If it does, then this is equivalent to that. And then do the same thing with 86.4 here, 54.12. Again, I'll set it up for you, but you'll do the work at home. And then, you can't really see it. There it is. Oh, oops. Jumping the gun a little bit. And do the same thing. Do they scale up with the same factor? Okay. And by the way, this will be, it doesn't work. Or does it? Let's find out. 5 times 5 is 25. That's 12, 125. 4 times 100. I'm kind of skipping a step. All right. Plus, you have 5, 2, 1, 1. 1 decimal point. Well, what do you know? Actually, it is equivalent. Hey! Okay, it does give you that. Wait a minute. No. Hold on. What did I do differently here? 112. Oh, I forgot to put the 0.5. It does work. Never mind. Phew! I forgot to put the 0.5 there, people. That little 0.5 right there makes a big difference. So that's equivalent. This is equivalent to that. You do the other two and figure out which one of those does not work. Okay? I'll do number 10 in just a moment. Okay, so the last problem to work on is number 10. Okay? Again, number 10 is one of those problems where it's not so much about the numbers. It's about the concept. Do you understand the idea? Okay, so we have the ratio of 5 to 7. 5 to 7. It can be whatever you want. 5 cars for every 7 motorcycles, 5 cats for every 7 dogs, whatever you want. The point here is that you have 5 whatever to 7 somethings, whatever you want. And it's asking, can you make 2 more ratios that are equivalent? Well, if you understand the idea that there's a relationship, a connection between this and this, if you want 2 more that are equivalent, that just means you want more of it, right? So maybe instead of just 1 copy of 5 to 7, maybe I want 2. Maybe I want two of the of the 5s, whatever the 5 is. You can choose whatever factor you want to scale up. It's whatever makes you happy. Maybe I want 100. Maybe I want to scale up by 100 because I want 100 of these. Right? It could be whatever you want. This would make it 500. And this would make it, again, since they are acting like fractions, whatever you do to the numerator, you do to the denominator. Whoops, wrong color almost. Now, the same is true. Let's say they gave you this, and they said, make 2 equivalent ratios to that. You can scale up if you want to something bigger, or you can simplify, right? You can do 50 over 70, 25 over 35 maybe, right? But the point is, I don't know if that worked out, but either way, the point is, use your imagination. The whole point is, you have a basic ratio, whatever it is. If it's small, if it's the simplest form, you just scale up and you get 2 more equivalent ratios. If you have a big ratio, you know what? Scale down, simplify it. And then from there, you can make as many more as you want and you get 2 more equivalent ratios. Okay? Don't be scared by the size of the ratio. If this happens, simplify it. Okay? And that's it, guys. I hope you like it.